Hey everyone, so I am in the Khan Academy Algebra 2 class right now, and I'm scrolling down to the units on rational exponents and radicals. So there's a lot of good videos on the rules of exponents and the rules of radicals and how things are written. There's a lot of cool stuff here, so I'd recommend that to get ready for the later lessons here. But what we're going to do today is focus on this lesson here, so solving exponential equations using properties of exponents. So taking all the properties and rules at the beginning of these lessons up here are teaching you all the basic rules for exponents, and then it's kind of wrapping it all together, putting it all together with solving equations here. So let's take a look at these questions and see what we can do. All right. So what I'm going to do here, so I'm looking at this equation. Let's get my pen out. All right. So in this question, on both sides of the equation, all I have is a base. So on the left side, I have the base 3 raised to the 7 minus 2x power. And on the right side, I have the base 1 over 27 raised to the negative 8 power. So what I'm going to do is I'm going to try to rewrite one of these so it has the same base as the other. So what I'm going to do is I'm going to actually try to rewrite 1 over 27 using 3 as a base. So the question is, and this is going to work out well. This is a textbook example, right? A lot of these are going to work out well like this. And what I'm seeing is I'm seeing how 3 and 27 are kind of related, because 3 cubed is 27, right? 3 times 3 times 3, because that's 3 times 3, which is 9, times 3 is 27. So what I'm going to do is I'm going to keep 3 to the 7 minus 2x on the left side, but I'm going to rewrite the right side as 3 to the negative 3 raised to the negative 8. And that seems really crazy, really weird. But what I want you to try to notice is all that I changed is I rewrote 1 over 27 as 3 to the negative 3. So I rewrote 1 over 27 as 3 to the negative 3. Why does that work? Well, with our exponent rules, I encourage you to look at those. Anything raised to a negative exponent is just 1 over the base raised to the positive version. So this is 1 over 3 to the third, which is 1 over 27, which we just said 3 to the third is 27. We just did that math out. So all I'm doing is I'm just rewriting 1 over 27 as 3 to the negative third. Why does this help me? So now what I can do is I can simplify this equation as 3 to the 7 minus 2x equal to 3 raised to the 24th power. Because when I have exponent, I have 3 raised to the negative 3. And if I raise that to the negative 8, I can multiply the exponent. So this is 3 to the negative 3 times negative 8, which is 3 to the 24. So now what I can do is, because the bases are the same, now what I can say is these two exponential expressions, these have to be equal to each other. Because if the base is the same, the left side and right side, the exponents now have to be equal because they have the same base. So to make these equal, 7 minus 2x has to equal 24. So all I'm going to do now is take 7 minus 2x, and set that equal to 24. Because what I'm saying is that if the base is 3, if I have an equation on the left and right side, the base is 3 on both. To make this equal, the exponents have to be equal. So that means that 7 minus 2x has to equal 24. So that means that negative 2x equals, I'll subtract 7 from both sides. So I get 17. Is that right? 4, 5, 6, 7. Yeah, see, that's right. Yeah. And then divide both sides by negative 2. So x is negative 17 over 2. Negative 17 over 2. So I'm going to put that answer in, and hopefully that gives me negative 17 over 2. Nice. So don't be afraid of weird answers like that. I just got that one right off the bat. All right, next question. Okay, so this question says solve the exponential equation for x. So same concept here. On the left and right side, we have two expressions, but the bases are different. So if we can get the bases to be the same, that means that we can just set the exponents equal to each other. So what I'm going to do is I'm going to rewrite 16 as a number with a base of 2. So if I rewrite 16, I'm going to rewrite it as 2 to some power. And the question is, what power is that going to be? And if you just kind of know your exponent rules, practice this, the number you're going to get here is 4. 2 to the 4th power is 16. Another way to think of 2 to the 4th power is 2 times 2 times 2 times 2. So what I'm going to do is rewrite 16 as 2 to the 4th. So this is going to give me, on the left side of my equation, 2 to the 9x plus 2 And on the right side of the equation, it's going to give me 2 to the 4th. So I'm rewriting 16 as 2 to the 4th, and that is raised to the 5x minus 2. So now what I can do, because I have the same bases, or actually what I'm going to do first is simplify this expression here, because I can multiply the 4 times the 5x minus 2. So this is going to give me 2 on the left side, 2 to the 9x plus 2, same thing. And on the right, I'm just distributing the 4 to the 5x minus 2. So that's going to give me 20x minus 8. 5x times 4 is 20x. Negative 2 times 4 is negative 8. So now at this point, what I have is on the left and right side, the bases are the same. So I can just set the exponents equal to each other. So 9x plus 2 equals 20x minus 8. I'll subtract 9x from both sides. So I'm going to get 2 equals 11x minus 8. Add 8 to both sides. 11x equals 11. So x equals 1. All right, so let's get that in there. X is 1. Oh, not quite. All right, let's pause for station identification, figure out. Oh, you know what? I got the issue already. So when you add 8 plus 2 is not 11. 8 plus 2 is 10. So let me quickly fix my answer here. My goodness, so go slow with this. This is not right. If I add 8, I'm going to get 10 equals 11x. Divide both sides by 11. I'll get x equals 10 over 11. So another example, don't be afraid of weird answers here. 10 over 11, and hopefully we get that right. There we go. All right, so let's clear drawings. All right, so this question here, solve the exponential equation for x. All right. So this one here looks pretty tricky off the bat, and this is definitely one where you can just kind of stare at it for a little while and not understand where to go or what to do. What you have to think about is the rule when you have an exponent of 0. So the rule is that anything to the 0 power equals 1. Anything raised to the 0 power equals 1. So the way we're going to get this to equal 1 is that the base of 26, this could be any base in the world. It could be any number, any variable, it could be anything. But if this exponent is 0, then the whole thing will equal 1. So all we need to do is set the exponent equal to 0. Because if the exponent is 0, the whole expression 26 to the 0 will equal 1. So we need to set the exponent of 9x plus 5 equal to 0. 9x equals negative 5. Subtract 5 both sides. X equals negative 5 ninths is our answer here. So negative 5 over 9. Very nice. All right, so what we're going to do here, similar concept to the first two we had. We have the number 7 as a base and 49 as a base. So what I'm going to do is rewrite 49 to have the base of 7. So on the left side, it's going to be 7 to the negative 9x plus 1. And on the right side, the 49, I'm going to write it as 7 squared, because that's just another way to write 49, and that's to the negative 12. So notice in the red, all I've done here is I've just rewritten 49 as 7 squared. So now what I'm going to do is simplify that exponent. So I get 7 to the negative 9x plus 1 equals 7 to the negative 24. So I'm multiplying the exponents 2 and negative 12. And now here I'm going to get negative 9x plus 1 equals negative 24. So I'm going to subtract 1 from both sides. So negative 9x equals negative 25. So that's giving me x equals, the negatives will cancel, and I'll get 25 over 9. And that should be fully simplified at 25 over 9. Okay. All right, so let me know through email or in the comments if you have any questions on this. I'd be happy to do another go at it. If the questions seem more challenging than the examples I got here, I would hope this helps. And yeah, adios.